Okay, so let's take a quiz over what you've learned today about fluids. So question number one, use the concept of pressure to explain what you should do if you're out on a frozen lake and the ice begins to crack. So we need to use the concept of pressure, and pressure is going to be the force you exert divided by the area. So if you're standing on the frozen lake, then the area is going to be the bottom of your shoes. So whatever the area in square inches, for example, of the bottom of your shoes, that's going to be the area. The force is going to be your weight. So let's say in pounds. So therefore the pressure is going to be in pounds per square inch. If you're using metric, then your weight is going to be in newtons, and then your area is going to be in square meters, so newtons per square meter or pascals. So we're going to use the concept of pressure to what should you do. So if you want to reduce your pressure, because it's the pressure that's going to be breaking the ice, so we need to reduce the pressure. So one way would be to reduce your weight. Well, you can't go on a diet when you're out on the frozen lake. So all that you can do is increase your area, and you could do that by laying flat. So that will increase your area and then decrease the pressure. Question number two, what variables control how much pressure a person feels at the bottom of a swimming pool? So what kind of pressure is this going to be? Static or dynamic? So it's going to be the static pressure, because it's going to depend on your position, how deep you are underwater. And so the static pressure is going to depend on what was the pressure at the surface of the water. So that would be atmospheric pressure. And then it's going to depend on the density of the fluid, which in this case would be water. And then it's also going to depend on gravity, 9.8, and it's also going to depend on how deep you are. Number three, explain why holding your finger over the end of a garden hose makes the water shoot out further. So this is going to be conservation of volume flow rate, which is going to be the speed of the water multiplied by the area of the hose. So at one end of the hose, it has a certain area and a certain velocity. If you put your finger over the end of the hose, you're decreasing the A, which means that the V, the velocity, needs to increase. And so if that velocity increases, that means it can travel a further distance in the same amount of time. Question number four, what is fluid resistance? So it is going to be when a fluid is flowing through a pipe, because of turbulence and properties of the fluid, it's not going to want to go through the pipe very easily. And we're going to call that the fluid resistance. And so the fluid resistance is going to depend on what kind of fluid it is, the length of the pipe, and then the radius of the pipe. Okay, how is pressure related to the volume flow rate? So here's the pressure, here's the volume flow rate, so they are linearly related to each other. So that if the volume flow rate doubles, then the pressure is going to double on it. And then you can also see that the pressure also is going to depend on the fluid resistance. And then question number 6, what is the buoyant force? So the buoyant force is the force that's going to be pushing up on an object when you immerse it into a fluid. And so the amount of fluid that is going to be pushed out of the way when you put the object into the fluid, you can measure the weight of that fluid. And then that, in turn, is going to be the force that's going to be pushing up on the object that you just put into the fluid. And so this is going to be Archimedes' principle. So that's kind of a summary of how fluids work. And so in our next lesson, we're going to start talking about heat, temperature and thermodynamics. So I'll see you then.